Uh, Hello, dear students. Today we are going to study about the salt analysis. The aim of the practical is to analyze the given salt for acidic and basic radical. We follow the general system. First, we do an experiment, then we observe, and then we write the inference. Uh, you can see that the given salt looks like this. So we are going to analyze this given salt, my dear students. You can see the salt easily, and then we can go for the physical examination of the salt. You can see that the physical state of the salt is solid, and that is why we can say that FeCl3 and other semi-solid salts are absent. Then we have the color of the salt. The color of the salt is white or colorless, and that is why the colorless, the colorful ions, or we can say that ions such as Fe plus 3, Fe plus 2, Ni plus 2, Cu plus 2, etc. are absent. Then we want to study the smell test. So let us look at the smell test for this particular salt, my dear students. Let us have a let us perform the smell test. For the smell test, my dear students, we need various materials. The various materials which are needed is original salt, distilled water, glass rod. Let us perform the smell test. So first we'll take the salt in a watch glass. Then we'll add a small amount of distilled water. Then we mix it, and then we smell it. We smell the rod, putting the rod near our nose. And what we can smell here is very simple to understand. You can see that when we smell it, we'll get the smell of ammonia, and that is how we can say that NH4 plus may be present. Now, my dear students, we are going to perform the next test, which is known as the dry heating test. So let us have a look at the dry heating test, my dear students. You can smell it, and you can easily understand that there we have the smell of the ammonia. For dry heating test, we need original salt, we need dilute hydrochloric acid, we need glass rod, we need test tubes, we need test tube holder, we need Bunsen burner. Let us perform the test. So we'll take our salt into the test tube and we'll heat on the Bunsen burner. On heating this, we get ammonia, and then we'll allow it to react with HCl. So for reaction with HCl, we'll dip a glass rod into the HCl solution and we'll bring that rod near the mouth of the test tube. Here you can see we have brought it. You can see that there are white fumes. These white fumes, let me show you once again. You can see that whenever we bring the glass rod, which is dipped into the hydrochloric acid near the mouth of the test tube, when we are heating the salt, let us see what happens. You can see the white fumes. These white fumes are produced because of the reaction of ammonia with hydrochloric acid, and NH4Cl is produced. You can see the white fumes again. These are the white fumes of ammonium chloride, and this is how we confirm the presence of, or this is how we understand the presence of ammonium ion. Let us perform the next few tests. The next test is the test of salt with solid sodium hydroxide, and let us heat it. So let us perform this this reaction. We will mix the salt with solid sodium hydroxide, and we are going to heat it. So the various materials required for this test is the original salt. We need concentrated sodium hydroxide solution, and then we need test tube, and then we need test tube holder, and then we need a glass rod, we need spatula, we need Bunsen burner and droppers. Let us perform the test. We take original salt, we add it into the test tube, then we add the concentrated sodium hydroxide, and then we just heat it. When we heat it, my dear students, again there is a reaction between the salt and the sodium hydroxide, and due to which ammonia NH3 is produced. Ammonia gas is produced due to this reaction. Then again we'll dip the glass rod into the dilute HCl and we'll bring it to the mouth of the test tube. Again there will be white fumes of NH4Cl because of the reaction of the ammonia with hydrochloric acid. This is how you can see. Then we'll move to the next test. So you can see that we have performed mixed the salt with the solid sodium hydroxide and heat it. We again get the smell of ammonia, and that is how we can say that NH4 plus may be present. So here the NH4 plus may be present, my dear students, and this is how we truly understand the presence of NH4 plus. Then we will mix the salt with solid oxalic acid and heat it. Then there is no smell of vinegar, and we can conclude that acetate ion CH3COO minus may be absent. Now, my dear students, we are going to perform the flame test. A pinch of salt is allowed to burn in the oxidizing flame, my dear students. When we burn the salt into the oxidizing flame, there is no specific flame or there is no other specific colored flame observed, and that is why the ions such as Ba plus 2, Co plus 2, Co plus 2, etc. may be absent. Now, my dear students, we are going to perform the wet tests. So, we are going to perform the various wet tests, my dear students. First, we shall take the salt and we shall go for the dilute acid test, and then we can go for the concentrated or sulfuric acid test. So let us have a look to the various tests, my dear students, that we want to perform today. Let us have a dilute hydrochloric acid test for the presence of the carbonate for the salt. So for that, we need the various materials required. What are the various materials we need? Let us have a pay attention. We need a solution of salt into the test tube. We need dilute hydrochloric acid. We need distilled water. We need test tubes, and we need droppers. Let us perform the test. We'll take the salt solution into a test tube. Then we'll add the dilute hydrochloric acid into it. When we add dilute hydrochloric acid, you can see that there are the effervescences produced. You can see it well. These are the various bubbles which are produced, which are the bubbles of a gas. You can see that. So these are the brisk effervescences that you can see here. Let us have a look at it once again. So these brisk effervescences gives us the presence of a carbon dioxide gas. You can see any carbonate when reacts with HCl, it produces the carbon dioxide gas, and this is how we understand the presence of the carbon dioxide gas. You can see the effervescences once again. Let me show you once again the brisk effervescences. Great. You might have seen the brisk effervescences, my dear students. Now the gas is collected into the test tube, and we are going to add the lime water. You can see that the lime water turns milky, and as the lime water turns milky, we can confirm or we can say that carbon dioxide gas is being produced by the reaction. Now we are going to understand the other test, my dear students. Let us try to understand one more test. That is what it is known as the dilute sulfuric acid test. So let us pay attention to the dilute sulfuric acid test, my dear students. For the dilute sulfuric acid, the material required are the original salt. We need distilled water. We need dilute sulfuric acid. We need test tubes and droppers. Let us perform the test. We'll take the solution, we'll take the original salt in the test tube, and then we'll add the dilute sulfuric acid into it. When we add dilute sulfuric acid into it, we can see that there are bubbles formed or there are effervescences that can be seen, and these effervescences or bubbles shows us the presence of the carbon dioxide gas, my dear students. So now let us note down the wet test. The first wet test is the salt plus aqueous dilute acid. Here in place of HCl, we can also use H2SO4. So we have also used H2SO4. When we add the dilute acid to the salt, we can see the brisk effervescence is produced, and this brisk effervescence gives us the presence of CO3 minus 2. So we can here say that CO3 minus 2 may be present. We also can go for the concentrated sulfuric acid test. So if we take salt and add concentrated acid like sulfuric acid, we may also get brisk effervescences, and that is what it confirms the presence of CO3 minus 2. Now, my dear students, we may perform the various tests for the other ions. For example, we can perform the manganese dioxide test. So we'll take salt and we'll add concentrated sulfuric acid and we'll add manganese dioxide, and then we'll add a copper foil and heat it, but we will not get any greenish yellow gas, and that is why we may say that Cl minus is absent. Then we'll take a barium chloride, we'll go for the barium chloride test. So we'll take salt and we'll add the barium chloride aqueous solution. We shall not get the white precipitates, and that is why we can say that SO4 minus 2 is absent. We can perform the brown ring test for the same salt which is given to us. In the aqueous medium, we take salt and then we add the freshly prepared solution of FeSO4, and then slowly by touching the wall of the test tube, we shall add the concentrated sulfuric acid flowing through the wall of the test tube. Ultimately, we get a brown ring. We do not get the brown ring at the juncture of both these liquids, and that is why we can say that NO3 minus is absent, my dear students. So from the various tests, my dear students, now we may conclude that there is a possibility that we have the presence of NH4 plus ion and CO3 minus 2 ion present with us, my dear students. So we may look at the presence of NH4 plus ion and CO3 minus 2 ion in our salt. Now we may go for the group analysis, my dear students. NH4 plus represents the zero group present in the group analysis. Thus we should confirm the presence of NH4 plus and with the help of the confirmatory test. So now, my dear students, we are going to perform the confirmative test for NH4 plus ion. The various confirmative tests that we can perform for NH4 plus ions are we are going to perform now, my dear students. So let us have a look the confirmatory test of ammonium ion, my dear students. The important test that we are going to perform for the confirmation of NH4 plus ion is known as the Nessler's reagent test. Let us perform the Nessler reagent test. For Nessler's reagent test, we need the various materials, which are original salt. We first need the original salt, then we need concentrated sodium hydroxide. We need Nessler's reagent, we need test tubes, we need test tube holder, we need spatula, we need droppers, and we need Bunsen burner. Let us perform the Nessler's reagent test. We'll take the original salt, we'll add it into the test tube, my dear students. We'll add a small amount of concentrated sodium hydroxide to the test tube, and we are going to heat it. When we heat it, we get the ammonia gas produced, my dear students. This ammonia gas is collected into the another test tube by so whatever, and now in this we are going to add the Nessler's reagent. When we add the Nessler's reagent, you can see that there are brown precipitates produced during this reaction. When we add this Nessler's reagent, we get brown precipitates produced, my dear students. Let us have a look to it. You can see here that there are brown precipitates produced when we add Nessler's reagent. Yes, You can see the brown precipitates are being produced. See brown precipitates, brown precipitates. Wonderful. These brown precipitates are produced due to the reaction of the natural reagent ammonia and the alkali. Instead of KOH, we have used sodium hydroxide NaOH, and this is how we get the brown precipitates. And these brown precipitates confirms the presence of ammonia, my dear students, with us. So this is how, my dear students, we can perform the various confirmatory tests for ammonia. You know what are the confirmatory tests for ammonia? The first is we'll take the salt and then we'll add the sodium hydroxide to the solution. When we'll add the sodium hydroxide and heat it, we'll get the smell of ammonia, and this smell of ammonia gives us the confirmation of NH4 plus ion. Then the next test that we are going to perform is the Nessler test, my dear students. So we'll take the salt aqueous solution and we'll add the Nessler's reagent. You can see that reddish brown precipitates are being produced, we have just seen, and that is what it confirms the presence of NH4 plus ion, my dear students. Now, my dear students, we are going to perform the confirmatory test for the CO3 minus 2 ions. So let us have a look to the confirmatory test for CO3 minus 2 ion. The very important test for CO3 minus 2 ion that we are going to perform is known as the magnesium sulfate test, my dear students. So let us have a look at the magnesium sulfate test. For magnesium sulfate test, my dear students, the various materials that we require are, let us see what are the materials required for the magnesium sulfate test. We need the original solution, that means the solution of the salt in a aqueous medium or water soluble or in a distilled water. Then we need magnesium sulfate solution. Then we need the various test tubes and the droppers. Let us perform the magnesium sulfate test. We'll take the salt solution into a test tube, my dear students. In this solution, we are going to add the magnesium sulfate solution, drop by drop. You can see as soon as we add the magnesium sulfate solution, what you can observe, my dear students, hello dear students, when we add magnesium sulfate solution, what do you observe?
White precipitates दिख रहे हैं.
Very good. So this is what you observe, and that is how you confirm the presence of what? This white precipitates gives us the presence of what? No idea? Look at this. Look at this. We have magnesium sulfate test. Can all of you see the screen, magnesium sulfate test?
Yes, sir.
Okay.
Yes, sir.
You can see that in magnesium sulfate test,
Yes.
aqueous solution of salt and then we add magnesium sulfate solution. What do we get? What have you seen?
White precipitates.
White precipitates are formed, and that is what it confirms the presence of CO3 minus 2. Another confirmatory test is the dilute HCl test. You have already seen it, that when we add aqueous dilute hydrochloric acid into the salt, we get brisk effervescence, and that is how we confirm the presence of CO3 minus 2, my dear students. So ultimately, we can realize that we have a basic radical NH4 plus 1 ion and acidic radical CO3 minus 2 ion present into the salt. So my dear students, this is how we, hello? This is how, my dear students, we perform the salt analysis for us, my dear students. Now, if you have any doubt, if you could not understand anything, you can ask me, my dear students.